So for this problem, you plan to order tacos and burgers for a group of people. Maybe you're at Del Taco, maybe you're at Carl's Jr., different places that have both of these. Hamburgers are $5 each. Tacos are $2 each. Now here, you want at least 3 tacos. So at least 3 tacos, and you want at most 2 hamburgers. So we're going to have to kind of include that in what we're going to be doing here. And we also know you can spend at most $30. So the most you have is $30. We're going to ignore tax. That's like ignore tax for now. And then here's what we're going to do. We're going to write a system of inequalities right here. You're going to create a graph from this right here. And you're going to find different possible solutions and write a sentence describing it for it here. So you'll see how this all come together. Something that actually you could do if you in real life wanted to figure purchases out like this. So in order to do this problem, I do need to start with one thing. I'm going to call hamburgers X and tacos Y. So hamburgers, I'm going to call X. Because I want nice little numbers. So hamburgers are X and tacos are Y. I think that's useful to start off with. So you could have called them H and T, but let's just go X and Y because we're used to it. Okay, so when we graph over here, when we graph this later on, X is hamburger. So what's this axis going to be? That's going to be your H, your hamburgers. And so the y-axis, which is right here, is going to be tacos. So when we get around to that, we got hamburgers by tacos. Let's see how that all pans out and makes some sense. So let's make several inequalities. First thing is, if hamburgers are $2, we'll come back to that. Hamburgers $5 and tacos $2. We'll come back to that. Let's talk about this one right here. You want at least 3 tacos. Does that mean you're buying more than 3 tacos or less than 3 tacos?
More.
If I say at least, does that mean the lowest amount is 3?
Yeah.
So I'm buying more than that? Got that? If I say at least, that means the lowest is 3, so I'm looking bigger. And what letter is tacos?
Y.
Tacos is Y. So my number of tacos is going to be bigger than or equal to 3. Does that make sense?
Yeah.
If I say at least 3 tacos, what of my tacos, number of tacos, be bigger than that? Now going back down here, should this technically be number of hamburgers and number of tacos? So that little pound sign means number. The X means actually number of hamburgers, and Y means number of tacos. That little pound sign on it means number. Okay, let's keep going. Next part. At most 2 hamburgers. Does that mean you're getting more than 2 hamburgers or less? If I say at most, isn't that the highest?
Yeah.
So for hamburgers, which are X, aren't they going to be below or equal to 2? I can have 2 or less. So I now know, by looking at this, I am getting more than 3 tacos, but below 2 hamburgers, or 2. My last sentence comes from spending $30. So my last, not sentence, my equation, or inequality, sorry. Well, here's what we got to think about. If it's $5 per hamburger, just think about that. Are you okay if I say $5 per hamburger? Wouldn't 5x give me how much I spent on hamburgers?
Yeah.
Just think. If I bought 10 hamburgers, would that be 10 times 5, $50? So won't this cover the cost of hamburgers? Plus, how much is it per taco? $2. So wouldn't that be 2y, giving me my cost for tacos? So if I bought 1 taco and 1 hamburger, would I put a 1 there and a 1 there? $7. But what does it say the most I want to spend? 30. So I want this to add up to 30, and don't I want it to be less than or equal to 30? Because at most 30. So want the highest amount be 30 possible. So this is the cost, and this is each individually. So the number of tacos has to be bigger than 3 or equal to. Number of hamburgers is less than or equal to 2. And this is the cost has to be below 30 bucks. We are now going to graph these three. But in order to graph this, would it help to rewrite it? I like to write it in slope-intercept form. So let's rewrite this last one. So I'm going to minus the 5x over. I now have 2y is less than or equal to negative 5x plus 30. And then can I divide by, what, 2? That's gone. So I now have y. Do I flip my inequality? Yes. I did not divide by a negative, so I do not flip my inequality. And that would be right there 15. Okay, so I have three inequalities. I have this one, and my new one now, which is a little bit easier to graph than the blue. We are going to graph these. Now to graph them, do we want to go by ones, or what are we going by? Well, our hamburgers are at most 2. So can I go by 1 on hamburgers? So I'll go by 1 here on hamburgers. The problem is, look at this. Isn't that a y-intercept of 15? If I have a y-intercept of 15, don't my tacos possibly get up to 15 tacos? Do you see that? So, I need to make sure I can get up to 15. So I'm going to go by 3s. On tacos, I'm going to go 3, 6, 9, 12, 15. So I made it to 15. That right there is a little tricky. You have to watch out for on these problems. In order to fit everything, do I have to on one of these go by something other than 1? And I noticed that right here because my y-intercept was 15. So let's graph these two and this last one here. The first one, y is greater than 3. Or my number of tacos is greater than or equal to 3. So tacos right here. So wouldn't that mean tacos would be 3 right here? And for y is greater than or equal to 3. Well, watch that. Doesn't that mean I have a line here at 3? And aren't we going greater? So when I lightly, very, very lightly, I have colors, but I would graph above y is 3. Y is greater than or equal to 3, so I put 3 tacos, and I shade it above. Now can we graph the hamburgers? Less than 2. So for hamburgers, isn't this 2 hamburgers right here? See 2 hamburgers? And which side would be smaller than 2 hamburgers? Isn't it lightly shading here? So far, can you tell my answer is right here in the top left? But don't we have one more inequality to play with? That needs to come in and make some adjustments. So let's graph this last one. My y-intercept is 15. So we're going to start here at 15. And what is my slope? Down 5 over 2. Okay, so I'm going to go down 5, which would take you down to a little bit above 9, which would be 10, over 2. So that's kind of hard, but wouldn't that take you to right there? Down 5 would be to 10 over 2. This is the number 2. And when I draw that line. And what side are we shading? Remember, we're doing this one right here. By the way, that's what we're graphing. What side are we shading? What's it say? The less than or equal to, which is the bottom. So that would be lightly shaded right here. Do you see a space that's shaded by all of them? Hopefully, I'm going to darken it. Hopefully you can see that space right here. I'm going to keep shading and shading and shading. Going to darken that up is my answer. Now we're going to talk about what does that represent. But that's our system of inequalities, right there in that shaded region. Here we go. So the next piece is a sentence. We want a sentence to describe an answer. Do you understand any answer would be in this shaded region? So I just want a combination of tacos and hamburgers from this shaded region. It could be any of them. I'm going to choose this dot right there. Could it be any dot in there? That dot right in there. I'm going to choose that one. That one is 1 hamburger. Are you okay? My hamburger is 1. And how many tacos is that? Isn't that 9 tacos right there? 9 tacos. So what that means is if I were to buy 1 hamburger and 9 tacos, I would follow all the requirements. Are there a lot more answers? Yeah. Could I choose this dot right here? Buy 1 hamburger and 6 tacos. Could I go over here and buy 2 hamburgers and 6 tacos? Yeah. What would this dot where they cross be? That's the maximum amount of hamburger and tacos to maximize your $30 worth. Would be right there in that corner. Farther to the right would get more and more money. And that is the idea. But don't forget to answer the sentence. Anything in here is a possible answer.